Assalamualaikum. We are from Group 4.
Introduction. Saponification is the process by which fat, oil, or lipids are converted into soap and alcohol by the use of an aqueous alkali such as sodium hydroxide. Saponification, in other words, is the process of making soap. Generally speaking, soaps are salt or fatty acid, which are themselves long-chain carboxylic acid. They are essential for maintaining people's cellular health and hygiene. Soap is required to remove oil and debris from surface, including the surface of our skin. In addition, soaps are widely used for household chores like cleaning and laundry. Objective: able to explain saponification process.
Okay, next we go to method and methodology. 5 ml of ethyl benzoate was mixed with 3 grams of sodium hydroxide in 15 ml of water in a round bottom flask. The flask was fitted to reflex condenser and a few boiling chips were added to the flask to prevent the popping. Next, the mixture was boiling gentle for 15 minutes until the layers separating. The flasks were cooled to the room temperature and the product was diluted with 15 ml of water. The aqueous layer for the oily layer was separated by using the separating vinyl, and the dilute hydrochloric acid was added while stirring the solution until the solution was acidic to litmus paper. The observation and the observation and the equation for the saponification of ethyl benzoate were recorded. Okay, for result and observation in this experiment, during the heating process, ethyl benzoate dissolved in water. White precipitate was formed around the round bottom flask during the heating process. Next, 2 layers of ethyl benzoate were formed during the heating process. After the addition a few drops of acid hydrochloric in the mixture, white precipitate, which is benzoic acid, was formed in the beaker. Next, the crude benzoic acid dissolved in the hot water during the solution in the beaker was heated. After the heating process, the needle-shaped benzoic acid crystals start to form. The cool down at the room temperature, and for the final pure benzoic acid was obtained. Okay, next for mass and for the mass watch glass plus filter paper is 32.288 and for the product is 0.605 gram. For direction saponification of ethyl benzoate is ethyl benzoate react with aqueous sodium hydroxide to form sodium benzoate and ethanol, and when sodium benzoate react with acid hydrochloric will form benzoic acid and sodium chloride.
We move to the separation process, which is because of the benzoic acid that is only weakly soluble in water at room temperature. Cool water was employed to rinse the crude product during the suction process. And to reduce the amount of benzoic acid lost during the rinsing, ice cool water is employed. And the last thing is a needle shape with crystal was observed. First thing first, the sodium hydroxide and ethyl benzoate was combined to create sodium benzoate and ethanol. The benzoic acid was dissolved in hot water, which served as a solvent. The cooling procedure was carried out gradually to reduce the possibility of contaminants becoming trapped in the crystal lattice as formed. For this discussion, we have highlighted 4 things. The first one is the formation of sodium benzoate. The process of saponification of an ester is utilized to form sodium benzoate solution and benzoic acid from ethyl benzoate. The white solid was formed due to the production of sodium benzoate. Also, 2 layers of greasy liquid has formed. It is because the poor mixing to the ester solution and the sodium hydroxide solution. So next is the color change of litmus paper. The pH paper turned from yellow to blue because of a strongly alkaline has combined. Then after a strong hydrochloric acid was added to the mixture, the litmus paper turned from yellow to red. This indicates that the mixture was acidic. In conclusion, the objective was achieved. We know that the saponification process is a process in which an ester reacts with sodium hydroxide to form sodium salt of an acid or alcohol. This process occurs based on the chemical equation below, which is an ester reacts in presence of an acid or a base to give back the alcohol and carboxylic acid. Okay, now we move to the next experiment, which is experiment 3, thin layer chromatography. The introduction of this experiment is thin layer chromatography. TLC is for analyzing the mixture of organic compound, and it's a technique that is for separating the organic compound and can be used to help determine number of components in a mixture, the identity of compound, and the purity of a compound. This TLC is a plastic sheet that has been coated with a thin layer of silica gel, which is a white powder. A drop of solution is analyzed and placed near the bottom of plate in the silica gel, and organic solvent are allowed to climb up the plate. And the next one is the retention factor. This RF is to measure the movement of the compound along with the TLC plate. RF is defined as distance traveled by an individual component divided by the total distance traveled by the solvent. Its value is always between 0 and 1. So here are the equation of the RF. Three objectives in this experiment. The first one is able to distinguish polar and non-polar solvent. The second is able to execute analysis technique using thin layer chromatography. And the last one is able to differentiate the retention factor RF for different compounds.
The procedure is a first sample are acetyl-aniline, p-nitroaniline, 2,4-dinitroaniline, and unknown sample will dissolve in acetone. The origin 0.5 cm from the bottom and the front line of the solvent 0.5 from the top are drawn on the TLC plate 3 times 5 cm using a pencil. The TLC spotter was used to placing the sample on the TLC plate on the origin line. The sample are allowed to dry, and the TLC plate was placed into the TLC container that contained chloroform 5 ml. The plate was removed from the container and left to dry at room temperature. When the solvent achieved to solvent front and leave it to dry at room temperature. The chromatography is placed under UV light, and the spots are marked by using a pencil. The RF value is recorded and calculated for each sample. The sample are run with the TLC scanner, and the result we discuss. The result RF value for each sample for acetyl-aniline, the distance traveled by the compound is 5.92, the distance traveled by the solvent is 80, and the retention factor is 0.074. For p-nitroaniline, the distance traveled by the compound is 27.8, and the distance traveled by the solvent is 79.4, and the retention factor is 0.35. Next, for 2,4-dinitroaniline, the distance traveled by the compound is 21.5, and the distance traveled by the solvent is 82.5, and the retention factor is 0.26. Last is unknown sample. The distance traveled by the compound is 20.5, and the distance traveled by the solvent is 81, and the retention factor is 0.25.
In general, low polarity compounds have a higher RF value than higher polarity compounds. The compound with the highest RF value and the fastest movement is the least polar, whereas the compound with the lowest RF value and the lowest movement is the most polar. We were also able to determine the compound that contained in unknown sample. From this experiment, the RF value of an unknown sample was 0.25, which is nearly similar to sample 2,4-dinitroaniline, which has an RF value of 0.26. Therefore, we can conclude that 2,4-dinitroaniline found in an unknown sample. According to the result, the sample's increasing polarity order is as follows: p-dinitroaniline, 2,4-dinitroaniline, unknown sample, and acetanilide. It shows that acetanilide is the most polar since it travels slower than other samples. In addition, TLC consists of 3 steps, which is spotting, development, and visualization. First, spotting. Spotting consists of using a micropipette to transfer a small of this dilute solution to one end of a TLC plate. In this case, a thin layer of powdered silica gel that has been coated onto a plastic sheet. The spotting solvent quickly evaporates and leaves behind a small spot of the material. Second, development. Development consists of placing the bottom of the TLC plate into a shallow pool of a development solvent, which then travels up the plate by capillary action. As the solvent travels up the plate, it moves over the original spot. Third, visualization. Visualization, a method that is used to render the TLC spot visible. A spot will interfere with the fluorescence and appear as a dark spot on a glowing background, while under UV light, the spot can be outlined with a pencil to mark their locations. However, there are some precautionary steps that needs to be taken while handling this experiment. First, carefully place the TLC plate inside the growing chamber once it has been detected and is ready to proceed. Second, use a good quality pencil for drawing the reference line so that the mark does not dissolve, which the chromatography is carried out. The last one is use enough solvent depending on the size of the chamber to travel up the length of the TLC plate.
So, the conclusion for this experiment is, from this experiment we have distinguished the polarity of four samples that has been used in this experiment. It is established that the unknown sample is a non-polar compound, while the polar compound is acetanilide. And the last one is the RF value of these four samples. It has been clear in the result.